Okay, so now we're going to talk about solving linear equations using multiplication and division, specifically equations of the form ax equals b. Notice now I'm going to have a leading coefficient. That leading coefficient is not going to be 1, so it could be 2, it could be -5, it could be some sort of a fraction, either way. So there are a couple of things that we need to start off talking about, and the first is what's called the definition of a reciprocal. Reciprocals deal with fractions. So a reciprocal, when talking about a fraction, is just a flipped fraction. And if you remember back from your studies of fractions, when you divide fractions, you multiply by a reciprocal. So, for example, if I had 1/2, my reciprocal is going to be 2 over 1, which is of course equal to just 2, right? So this is my reciprocal. Same thing if I had 3/4, my reciprocal is going to be 4/3. And then another thing that we probably need to bring up is, what if I had a whole number? What if I had something like 5? Well, remember that any whole number can be written as a fraction just by putting it over 1. So 5 is actually equal to 5 over 1, which then my reciprocal would then be 1 over 5. Okay, so all of these are finding reciprocals. And that's going to be very important, because if I'm going to be solving these, then I'm going to need to find the reciprocal. So if I want to clear, so remember our goal. Our goal is to isolate the variable. So our goal is to isolate the variable. That just means get the variable all by itself. And the way I do this is if it's a coefficient, so to remove the coefficient, what I need to do is I need to multiply or divide whichever's the opposite. So I do that by multiplication or division, whichever is the opposite. And this is kind of a misnomer. Really, the entire time I'm going to be doing division, but it's going to look like multiplication in several places. So let's get started. Okay, so the first problem we're going to work is 4z is equal to 2. Well, let me start off by saying that I really hate working with z's. They just look too much like 2's. So be very careful. When you're given a z, I don't care if you change these to an x and work with them as an x, that's fine. But if you do choose to use them as a z, make sure you have these start curves and that you put a little line down the center, and that's going to distinguish that as a z. Well, I don't have any numbers on the side to add or subtract to move, right? So I just have to get rid of this numerical coefficient. Well, we have to remember that what's happening between 4 and z, what's happening between the coefficient, is multiplication. So this is 4 times z. Well, what's the opposite of multiplication? That's division. So I need to divide by the coefficient of 4. Well, 4 divided by 4 is just going to give me 1. That's going to leave me a coefficient of 1. That's going to get my z by itself. So that's just going to give me that z is equal to 2 over 4, which then will reduce. So as I kind of indicated in the last video, what that would look like is, well, 4 is simply 2 times 2. And then, of course, I have a 2 up here at the top. Well, 2 divided by 2 just gives me 1. That's what we really mean when we say it cancels. So I'm left with 1 over 2. Okay, so our next question is going to be this -2 is equal to -3v. Again, it doesn't matter which side of the equal sign your variable is on. What we're going to do here, again, nothing to move. I don't have anything added or subtracted to the end. So what I need to do is I need to divide. Well, I need to divide by the exact coefficient. Well, here my exact coefficient is -3. So I need to divide by a negative 3. Well, negative 3 divided by negative 3 is going to be 1. So that's going to cancel. And then I have to divide this side by negative 3 as well. Well, remember your sign laws. If my signs are ever the same, I'm always going to get a positive number. So negative 2 and negative 3 is going to give me a positive 2/3. Okay, now we're going to work on something that looks a little different. Now I've got some numbers that are being subtracted here. I've got some numbers that are being subtracted here. Be careful with this. Remember, our goal is to isolate our variable, isolate our y here. I don't want to move anything over because that's just going to end up breaking them up. I want to make sure that I can get them together before I do any kind of moving. Simplify as much as you possibly can before doing any of that work. Okay, remember your sign laws. If I've got a positive 5 and a negative 8, my negative number is bigger, so my final answer is going to be bigger. Is going to be negative. So 8 minus 5 is, of course, going to give me 3, so I'm going to be left with 3 y's. But now I need to be careful here because my larger number was negative, so my answer is going to be negative. So I'm going to be left with negative 3y. Then I have negative 5 minus 4. Again, let's clean up as much as we can before we get started. So negative 5 and negative 4, those are going to combine to give me negative 9. So that's going to give me negative 9. Well, now we can do, we've got to divide. Again, the opposite of multiplication between negative 3 and y is going to be multiplication, so the opposite is division. So a divide by negative 3, remember it has to be exact. So my negative 3's cancel, leaving only y. And then I'm going to have negative 9 divided by negative 3. Well, 9 divided by 3 is 3. Negative divided by negative is a positive, so I'm going to be simply left with y equals 3. This is going to be one of those that would be easy to check. Just plug in the y, plug in the 3 for the y's, and you'll be able to see that they equal the same thing. Okay, so now we're going to deal with some fractions. Okay, so I want you to go back. I want you to remember what we talked about reciprocals. Reciprocals are the opposite, or a flipped fraction, and any number can be written as a fraction by placing it over 1. So we have a little bit of work that we need to do here first. It's going to look really ugly if I try to divide by negative 4, and then I'm going to have 7/5 divided by negative 4. It's going to look a little weird. So since I have this fraction, what I need to do is I need to multiply it by the reciprocal. That will make my life much, much simpler. But before I can find the reciprocal, I need to make this a fraction. So remember, negative 4 is the exact same thing as saying negative 4 over 1. Okay, so I'm going to rewrite it that way. So this is negative 4 over 1z is equal to 7/5. Well, now I've got a fraction here, so I'm going to clear a fractional coefficient by multiplying by its reciprocal. Well, my reciprocal of 4 over 1, what do you think that's going to be? Well, I'm going to flip that fraction, so it's really going to be 1 over 4. So this is negative 1/4. That's going to be my reciprocal. So I'm going to take my reciprocal over here, and I'm going to multiply by it. So multiplying by negative 1 over 4, and again, if I do it to one side, I have to do it to both sides. So multiplying. Now guys, don't panic when it comes to fractions. There's a little rhyme that will help you. Multiplication with fractions, that's no problem. It's the top times the top and the bottom times the bottom. So don't let that freak you out. So 1 times 4 is just, of course, going to give me 4. And 1 over 4 is, 1 times 4 is just going to give me 4. Negative times negative gives me positive. So I'm just left with 4 over 4z. And then this is going to give me 7 times negative 1. That's just going to give me negative 7. And then 5 times 4 is going to give me 20. Okay, well, that's not bad. 4 divided by 4 is just going to give me 1. So we say that those cancel out, just like we did at the very first. So this is just going to give me z is equal to negative 7 over 20. Okay, so same type of question. Again, I've got this fraction over here. I know I'm going to have to multiply by the reciprocal. I'm going to have to multiply by this reciprocal because that's the only way to get rid of a fractional coefficient, at least that you currently know. We'll talk about in later sections another way to remove them, but at this point, know that that's how we're going to do it. Now, so I know I'm going to have to do that. Well, I want to make this a fraction too. Again, it makes it easier if everything is a fraction or everything is not a fraction. So I'm going to go ahead and rewrite this as 2 over 1 is equal to negative 7 over 9w. Okay, well, let's talk reciprocals. What is my reciprocal of negative 7 ninths? Well, reciprocal is just a flipped fraction, so the denominator goes to the top goes to the bottom. So this is going to be negative, my reciprocal is negative 9 over 7. Well, I'll have to multiply that to both sides. So negative 9 over 7, and again, don't panic just because it's a fraction. Multiplication is top times top, bottom times bottom. So 7 times 9 is 63. Negative times negative is positive. So I get 63w over 63. 2 times 9 is, of course, 18. So this is negative 18. 7 times 1 is just 7. So this is going to give me 63 divided by 63. They divide out to give me 1. So they cancel. So that's just going to give me w is equal to negative 18 over 7. Now you may ask yourself, in the last two problems I worked, up here, negative 7 over 20 or 18 over 7, I didn't check to see if I could reduce. Well, I've been working with fractions long enough to know that I can't. But that's not a good excuse for not checking it. So let's talk about how I would know if those are reducible fractions or not. Well, let's talk about 18. 18 is simply 2 times 9, and 9 is simply 3 times 3, right? So I could replace 18 with its prime factors of 2 times 3 times 3. So let's do that. So we had 18 over 7. We're going to replace that with 2 times 3 times 3. Well, 7 is prime. 7 is just 1 times 7. That's all I could multiply by. So that's just 1 times 7. Well, notice there's nothing on the top and the bottom that could cancel. So, since that's the case, there's no reduction that can take place, and I'm finished. So I'm left with w is equal to negative 18 over 7. Okay, that concludes the lecture over this section. And if you have any questions, don't hesitate to shoot me an email. Thanks so much.